Want to make a game like Jelly Cars? Jelly Cars is a physics-based game made using something called soft body. And if you're familiar with Godot, you would know that making a soft body 2D in Godot is super hard and frustrating. But with this Godot soft body 2D plugin, this process is a lot easier. Now with a click of a button you can create a soft body 2D that would normally take hours to make. Without further ado, let's get into it. First you have to download the plugin from the link in description. Then open your file manager and copy add-ons folder from the zip file you've just downloaded directly to your Godot project folder. Finally head over project settings, plugins, and check soft body 2D. Now you can add a soft body 2D node to any scene you want. But first, there are 4 types of soft bodies: bouncy, slippery, breakable, or you can create your custom one. So, I added a soft body 2D node and duplicated it twice, so now I have 3 soft bodies. I selected all of them by holding the control button on the keyboard, dragged the Godot icon to the texture field, and changed the rest length to 2. The higher the rest length, the softer the body becomes. To better observe the difference, let's compare 2 soft bodies, one with a rest length of 10 and the other with 0.1. Can you see the difference? Okay, going back to our 3 soft bodies, I changed the collision shape radius to 15. Then I clicked on Bake, and the soft bodies were ready. But before that, let's move these bodies a little bit. Drag the bouncy physics material onto the bouncy body, click Bake. Drag the slippery material onto the slippery body, and attach the breakable script to the breakable body. If you have completed all of that, hit play and watch your soft bodies jiggling around. Finally, if you found this tutorial useful, you can buy me a coffee from the link in the description or visit my other channel for game devlogs.
The first thing that we're going to be doing is learning about navigation region. So the first thing we'll take a
Let's say you're designing an enemy. You want this enemy to wander until it spots something, then chase that target, and if it gets close enough, give it an attack. How would you program this? It would be super simple to check whether there's a target and whether we're in range, then handle the different time for wandering and all the randomness. But imagine you added a few more states to that. Maybe you could see how this code would grow larger and larger. Even though this is a smaller example, I personally would use a finite state machine. First off, before we define a finite state machine, we should probably define what a state is. A state is a set of conditions and a behavior to go along with it. So our wander state from before had the conditions that there was no target, and the behavior is wander randomly. And of course, our chase behavior was that we have a target, and that we're not in range, and that behavior is to chase. And that's kind of how we would split things up in code. So we would have a state class, and that behavior is to chase. And that's kind of how we would split things up in code. So we would have a state class, and inside of the state class, we would have a couple of methods. The first 2 are enter and exit, which are called when we transition to a state and leave from a state. Then we'll have 2 functions. Those are the update and physics update functions. The update is tied to the visual frame rate, whereas the physics is tied to the physics server. Then each state can have its own relevant information. For example, the wandering state would probably have a random direction, and maybe a speed, and maybe a time for it to wander. Then, inside of the inner function, we would randomize these variables, and on update, we would tick down the timer, and if it reaches 0, we would randomize the variables again. Then, inside of physics, we would probably move. And for all of the other states, it would probably be a very similar story. That's basically it for the state, and the finite state machine is simply just a collection of these states. So in our case, we would have an idle, chase, and attack state. These would all belong to one state machine. The state machine itself is responsible for handling the life cycle. So for example, if we're moving between states, it's responsible for calling the exit function on the previous state and the inner function on the new one. And it's also responsible for keeping track of what the current state is. Usually, the actual state machine is completely agnostic to what states are inside of it. It just needs to know what the current state is and what state you want to move to. So let's swap over to Godot and we'll give this a shot. So we're back in the project from before, and all I've got is this little dude. He's got a script on him that just calls move and slide, and we'll set the velocity later using the states. So the first thing I'll do is add a new state script. This will be the base script used for all other states later, so we'll set up the functions in here. We'll declare class name state and define the functions enter, exit, update, and physics update. All of these will just contain pass because we don't actually want to do anything in these functions right now. You technically could, but for our project, I'll just leave these blank. Next, I'll go ahead and add a new node to the enemy and just call this state machine. Then I'll attach a new script. So the plan is to have the state machine in the scene tree, and every state can just be a child of that node. So what I'll do is I'll define a states dictionary, and then inside of the ready function, I'll loop over all of the children. And if the child is a state, I can add it to the dictionary by using its name. And since state extends node, we can check directly here whether it's a state or not. I'll go ahead and track the current state, and then we'll go ahead and define the process and physics process functions. And inside of here, we can check if we have a current state and call update and physics update respectively on the current state. But how do we move between states? Well, there's a billion different ways you could do it, but in my personal way, I would use signals. We'll head back over to the state class and add a new signal transitioned. Anytime we on the current state, but track the current state, and then we'll go ahead and find a states dictionary and then machine. Then I'll attach a new script. So the plan is to have the state machine in the scene tree, and every state can just be a child of that node. So what I'll do is I'll define a states dictionary, and then inside of the ready function, I'll loop over all of the children. And if the child is a state, I can add it to the dictionary by using its name. And since state extends node, we can check directly here whether it's a state or not. I'll go ahead and track the current state, and then we'll go ahead and define the process and physics process functions. And inside of here, we can check if we have a current state and call update and physics update respectively on the current state. But how do we move between states? Well, there's a billion different ways you could do it, but in my personal way, I would use signals. We'll head back over to the state class and add a new signal transitioned. Anytime we want to leave the state, we'll just call this signal. And inside of the state machine, anytime we register a new state, we can simply connect to the transition signal. This will connect to a function that takes in the state that called it, and the new state name that it wants to transition to. We can check if the state calling it is not the current state, and then we'll grab the new state from the state dictionary, and of course make sure that exists. Then we'll check if we have a current state. If we do, we'll call .exit, and then we'll call .enter on the new state and set the current state to the new state. One quick thing is down here I use toLower, and I will actually add that up here as well, just to make sure capitalization doesn't do anything funky. And then one last thing is I'll add an exported variable called initial state, where we can define the initial state that we want the state machine to be in. We'll check if initial state exists, and if it does, we'll call .enter, and then we'll set current state to initial state. And then next, we can start building out our separate states. The first state I'll make is just idle. I'll start by making a new script, and I'll just call this enemy idle. Instead of extending node, we'll instead extend state, and set the class name to enemy idle. And inside of this state, we'll have the two randomized variables, which are move direction and wander time, and then a function to randomize those variables. And then when we enter the state, we'll just call that random function. And then the update function should be really simple. We'll just check if wander time is greater than 0. If it is, we'll tick down using delta, and then otherwise, we'll just randomize these variables again. And then for the physics update, we'll actually add two more variables. These are a reference to the enemy that we're going to be updating and the move speed that we want to update to. Then in the physics update, we'll check if enemy exists, and if it does, we'll just set the velocity to direction times speed. And then of course, we probably want to test this to make sure this works before we go any further. So I'll go over to the state machine and add a new node. If we search enemy idle, we should see this here, and I'll assign the enemy, and then I'll assign the initial state. Then if I go in game, it looks a little jank, but he's definitely moving around. And just for visuals, back in the enemy, I've added it so that if we're moving, we're going to play the run animation and flip the sprite based on which way we're going. And that already looks a lot better. I'll go ahead and rename this to just idle, and we'll do one more state together. So back down in states, I'll add a new script, and this one will be enemy follow. And just like before, we'll extend state and set up the class name. And we of course need to know what we're following. For this example, I'll just assume we're following the player, and I'll add the player to its own group. Then I'll add a player as a target, and inside of the inner function, I'll just grab the player from the group. And for the physics update, just like before, I'll add in a reference to the enemy and the move speed. And then inside of the function, we'll get the direction between the player and the enemy. And if it's outside of some distance, we'll move the enemy towards the player. Otherwise, we'll have it stand still. And of course, we want to test this one too. So I'll add it as a child. I'll assign the enemy and set the initial state to the follow state. And I'll also rename it to just follow. Then if I go in game, he follows. So the last thing to do is moving between states. This is very much state dependent, and I think it's a lot easier if I do it for the follow state first. So for the follow state, we want it to go back to being idle once we've reached a certain threshold. So I'll say if the distance is greater than 50, we'll call transition.emit. Note that we're passing in the current state and the name of the new state that we want to go to. And if we give this a shot in game, we can see that he stops following us after a certain distance. And back in idle, we can do the exact same thing. Of course, we'll need a reference to the player, so we can grab that from the tree. And inside of physics update, we can grab the direction between the player and the enemy, and if it's within some threshold, we can then transition to the follow state. And if we give that a shot in game, you can see he swaps to idle, and if we get close, he starts to follow again. That's the absolute basics of a state machine, but there are a lot of things you could clean up about this. For example, you notice how both of these states have access to the enemy, but instead of having access to the enemy directly, there could be an intermediate state object that these states modify, and the enemy just grabs every frame. Or since you notice that these three variables are duplicated between idle and follow, you could extract them to an enemy state class and have all of the enemy states extend from that. But regardless of that, I hope this is a good look at how state machines can be used.
Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to another Godot tutorial video. In this video, we're going to create a simple, well, actually, it's going to be a slightly more advanced finite state machine, and we're going to program some AI for this little goblin right here, this little business goblin. The idea is when we move the mouse around on the screen, if the goblin can see the mouse, then it will follow the mouse. And if it can't see the mouse, then it will just kind of wander and bounce off the walls. So let's start by creating a new script. Over here on the left. Oh, you can see that I've got some projects set up right here. There will be a link in the description. I apparently can't use pinned comments anymore. YouTube actually went through and deleted all of my pinned comments. And I guess I'm not alone in this. I looked it up, and there are other creators who have had their pinned comments deleted by YouTube. Not sure what's going on there, so there will be a link in the description. So now let's create a script. Yeah, so you can use that link to download this project at this point right here that we're at, so you can follow along. And we'll
hands and lights can't stop me. I'll just hold on for dear life. Yeah, I can't give up this feeling that I get when looking down from the sky. When I'm with you, when I'm with you, I'm with you, that I get when looking down from the sky. Those hands and lights can't stop me. I'll just hold on for dear life. Yeah, I can't give up this feeling that I get when looking down from the sky. When I'm with you, when I'm with you, give up this Without you, I remember myself, my name. Forgot about all you tried to change. Familiar was the sound of your voice as I continue to walk on by. It has been a year and now I'm living on the line. It has been a year and now I'm thinking what's mine, that I'm better off right here without you.
My emotions, I can't seem to control them. My emotions, my emotions, my emotions, my emotions, my emotions, my emotions, my emotions. Every day is a mess when sometimes I feel like I'm trapped in because of my emotions. I can't seem to control them. Every day is a mess when sometimes I feel like I'm trapped in my emotions. I can't seem to control them. My emotions, my emotions. My emotions, my emotions, my emotions, my emotions, my emotions, my emotions.
We'll call this finite state machine. So a finite state machine is well, let's rename that actually, because I prefer using lowercase now. oops, but we'll give the class, we'll do class name finite state machine. Okay. And save, just like that. The finite state machine is just a way to run code on an object or entity or whatever, and have it only run certain bits of code at a time. So, and this can create states that your character is in. So you can have your chase state or your wander state. And while you're in the chase state, you won't run any code from the wander state. While you're in the wander state, you won't run any code from the chase state. And it separates out the logic and makes it a lot easier to handle. Plus, you can reuse these states on other objects. So let's say you have a different enemy that has a chase state, but it doesn't have a wander state. Maybe it just stops and is idle. You can reuse your chase state code. So it gives you reusable code as well. So the first thing we need to do is our finite state machine is going to be the class that handles the states, and its job is going to be switching. It's going to store the current state, and it's going to switch the states or change state. So let's give it the current state. We're going to do an export here, and we're going to export our state. And for now, we're not going to type it, but we eventually will type that. Without a type or initializer, fine, we'll type it as node for now, so it doesn't get mad at us. Okay. Now we're going to create a ready function, and in this ready function, we're going to call change state, and we'll change to the state. That just makes sure we initialize this first state right here. Now let's create that change state function. We'll say new state, and we'll type it as node for now. We're eventually going to change that to state. You know, a bunch of our code requires us to have the state class. So let's create it now. We'll come over here and we'll create a new script. And this script will be called state. Great. Come into it here and we'll give it a class name. State. Code require stand state, and we'll change to the state. That just makes sure we initialize this first state right here. Now let's create that change state function. We'll say new state, and we'll type it as node for now. We're eventually going to change that to state. You know, a bunch of our code requires us to have the state class. So let's create it now. We'll come over here and we'll create a new script. And this script will be called state. Great. Come into it here and we'll give it a class name. State. And we're going to give it a couple functions. So we'll give it we're going to give it a signal as well. Let's give it a signal called state finish. This will just be kind of like a default, this state is done running signal. We'll create a function called enter state. And this will return void. Pass. We'll create another function called exit state. No, not tree. State. It will also return void, and we'll just pass. These are functions that when we create new states, they will inherit from this, and we will extend these functions. We'll add code to them based on what we want that state to do when it enters. Okay, let's come back to our finite state machine, and now we can type this as a state, and down here as well as state, because we want our finite state machine to deal with the state nodes. Okay. Now we need to finish writing the change state logic. So we'll say if state is state, then we'll do state dot exit state. So this is the previous state, right? It's not the new state yet. So we're running the exit code for that state, but only if it's actually a state. If it's null, which could be possible, then it won't try and run that function. Now we'll say new state dot enter state. So now with a new state, we're going to call our enter state function. And then we'll actually update the state variable to reflect the new state. State equals new state. Pretty simple. Okay, now we have the basics for our finite state machine. We can come back to our goblin here and we can start creating the states. You can see I've already set up a shadow, collision shape, and everything, but we're going to need to create our finite state machine. So let's add a new node and we can search finite state machine. And you can see because we gave our script a class name, it's showing up here, and we can add that right from there. So now we're going to need a couple states for our goblin. So let's start with the wander state. We're going to right click over here. We're going to create a new script. And this script is going to inherit from state. And we're going to call this enemy wander state. Create it. And you can see if we come into our enemy wander state, it extends state. We'll give it a class name. Enemy wander state. Like this. And let me check to make sure I'm actually got recording audio. Okay, I am. Okay, so we've got our enemy wander state. Now our state is going to need an actor. And this is going to be the thing that our state manipulates. So let's do an export variable for this. And we'll call this actor. It's going to need to be a so if we come into our business goblin here, we've got a script attached to it. So let's call this, let's see, what did I name it? I named it businessgoblin.gd. So we'll give it a class name. Business goblin, like that. And it's going to have a couple variables that we'll be using. So let's give it an export variable, max speed, set this equal to 40, and an export variable of acceleration. We'll set this equal to 50. Let's just do max speed, acceleration, that. Okay. So business goblin, although probably ideally we would want this to be just like a base enemy class like this. So we'll do that. We'll come back into our wander state and the actor is going to be an enemy, just like that. And also in our wander state, we're going to need access to an animator. So var animator.
We want to explore. The thing we're going to do is let's start with our player. I have my brush, there we go. Here is our player. And this will consist of the actual scene of the player and the script. So we have a script plus the player. Okay, now this guy, this object, is going to be connected to a class called character body 2D, which you might be familiar with. Now this character body enables the player to do things, including have gravity, move and slide, all these functions that you already know that the player can do. Now we want to create a state machine. So let's create a new diagram and have this called states or state. Now this state will consist of two subclasses. I'll have one here. This will be the idle state. And then we'll have another. And this will be the walk state. All right, so let's see if we can understand this a little bit. So these states over here, so all these states is a class. Each one of these are classes. So the walk state and the idle state are subclasses of the state. And the state is a subclass of the player itself. Or not a subclass, but more so a connection, a node of it. So in our state, we're going to have things like speed. So we'll say variable speed equals 40, max speed, whatever. We'll also do change. We'll also have a function called change state. Okay. And we can pass through, for example, idle. Now this will allow us to go from walk state to state and then to idle state. So it'll allow us to change states. Okay. So if I called change state from here, so if I say change state, if I can type, there we go, to idle, we will go here, figure out what's happening, and then go into the idle state. Okay. Things like code, all these states. Is a class. Each one of these are classes. So the walk state and the idle state are subclasses of the state. And the state is a subclass of the player itself. Or not a subclass, but more so a connection, a node of it. So in our state, we're going to have things like speed. So we'll say variable speed equals 40. Max speed, whatever. We'll also do change. We'll also have a function called change state diagram and have this called states or state. Now this state will consist of two subclasses. I'll have one here. This will be the idle state. And then we'll have another, and this will be the walk state. All right, so let's see if we can understand this a little bit. So these states over here, so all these states is a class. Each one of these are classes. So the walk state and the idle state are subclasses of the state, and the state is a subclass of the player itself. Or not a subclass, but more so a connection, a node of it. So in our state, we're going to have things like speed. So we'll say variable speed equals 40, max speed, whatever. We'll also do change. We'll also have a function called change state. Okay. And we can pass through, for example, idle. Now this will allow us to go from walk state to state, and then to idle state. So it'll allow us to change states, okay? So if I called change state from here, so if I say change state, if I can type, there we go, to idle, we will go here, figure out what's happening, and then go into the idle state, okay? Now, in our actual state, we will be able to set up these states and do all that stuff inside of Godot, which I'll show you how to do. However, inside of these states, right, inside of the idle and walk state, we want to figure out what to do. So first of all, we need a condition that will help us go from walk state to idle state, right? So that condition is essentially if not moving, then change idle, right? If I can type, or I don't know, I can't do anything. Now from our idle, we want to go from idle to change to walk state, and we can do that by adding a condition if moving, right? We'll show you how to do that in a second. We'll say if moving, then change to move, or walk in this case, right? So this will allow us to, we have now two conditions that will allow us to go from idle, or from walk to idle, and from idle to walk. Okay, so now let's take this into Godot and explore how to actually do this in code. So in Godot, let's open up our Godot project. Now I've already finished everything essentially. However, I'll basically be going through everything that you need to know. So let's go into our player, and let's look at our setup first. So here we have the floor, so it's a static body, and I've shown the collision shape. And here we have a player as a character body 2D. And if we look into our script, we just have a script that extends the character body. We have a variable called state, and in our ready state, we also have gravity. And let's look at our physics project, actually very easily. So we have move and slide so that our player actually moves and slides. And then we just have gravity. So this is gravity to allow us to push our player down. Now, the rest of the movement is handled within the states, okay? So in our state, or in our ready function, we're going to create the node state to hold our states. So here we say state is equal to state.new, and then we're going to name that state node that we just created, and we're going to name it to state, so it's not named gibberish. And then we're going to add the child to our player, and then we're going to change the state in our idle. So we're calling a function inside of our state machine essentially. Okay, so let's take a look at our state script. So here I have, as we said from our diagram, we have set the speed, right? So we have speed, and we have max speed and acceleration, and we also have states and current state. So states will hold all these states that exist within the game, okay, or within the player, I suppose. So we have idle and walk. All right, now we also have current state. This will allow us to hold the current state outside of the change state function. Now we'll look at the change state function in a second, but let's go to our idle state. So in our idle state, the first thing we want to do is get access to our player. So in order to do that, we just say ready at ready function. We say get parent.getParent. Now when I play, let me show you why we do that. Because here's our idle state node. we get parent, we go to state, and we get parent one more time. Now, unfortunately, I'm not sure why actually. If you have the answer, you can actually let me know. I tried getting access to the player inside of the state, but it wouldn't let me. I'm not sure why. So it just wouldn't really persist. So I ended up having to get access to the player individually inside of each state. So if you can figure that out, definitely let me know in the comments below. But in either case, we will get access to the player inside of each walk state and idle state within the state itself. So in our idle state, let's go back to our idle state. Here we have access to our player. And now here in the physics process, let's ignore this for now. Let's cut that. Here we have setting the player's velocity to 0 essentially. So this lerp function essentially takes our current player velocity and sets it to 0 over a certain amount of time. So it basically slows our player down. It's kind of like friction. Okay, this is kind of how I like to do it. So either way, you could just set it to 0 and it's like the same thing. All right. So we talked about conditions to allow us to change states. Now remember here from our idle state, we want to move. We want to say if moving, we want to change to move. Now the way I did this is really simple. So because we're in a platformer, all we can have to do is say if input is action pressed, UI right, then we'll change to walk. And elif is action left clicked, then we'll change state to walk. Right? You could also just take this and say, or is action pressed. That could probably also work, but I just did an elif statement just for having it fit on the screen. So now in the walk state, remember in our diagram, we want a condition to go from the walk state to idle state, right? So here we can see that if we're going to check for movement from the right and left, now let's ignore that and see else. So the else essentially is us telling us, or the state is telling us, okay, we're not moving anymore. So let's change state to idle. Okay. Now this velocity will allow us to basically set the velocity to a velocity that I like to do. It kind of maximizes it. So this is kind of the equations that I use. So don't worry too much about this actual equation, but if you would like to use this in your platformer, go for it. Okay, so in the state, let's take a look at the change state now. The change state basically first checks to see if we have a child. Now, the beauty of this change state is that it will only allow us to have one state at a time. Now, if you don't want that, you would have to figure out some other way to change states or whatever. But this is the way I've done it. So first we check to see if our child count is not 0, meaning if we do have something, we're going to get that child. So get child idle or 0 and queue free. We're going to destroy it. Okay, now that we've destroyed it, we're going to now get the new name in our dictionary. So let's say I pass through walk, right? I pass through the string walk. I want to now get the walk state and create a new node. So I'm going to basically say this, walkstate.new. Okay. And then I'm going to do the same thing as in from my player, right? So here we set the name and then we add child, and that's it. So we set the name and then we add the child, and that's it. That's all I have to do to change states. It's really easy. So all I do to change states is I add and destroy the children. Okay. So, or I destroy and then add the children in that order, because I don't want to add and then destroy. It kind of messes things up. And so now we get a nice smooth walk state. Now, if I go into remote, I should be able to see it change manually. There you go. You can see it change from walk to idle and walk and idle to walk. Okay, and you can see it's a little delayed, but that's okay. That's just the remote being a little slow, and that's it. So hopefully you guys have learned how to bait state machines and how that actually works. If not, I wish you luck, and I'm sorry I couldn't help you out, but